This rock is the Shinumo quartzite, one of the tilted layered rocks, the middle set of rocks in the Grand Canyon. It's a super resistant rock. It was laid down as a sand on a beach, so it was a beach sand. And then when it was sitting there on the beach, it had water in the pores before it became a rock. And somewhere, we don't know where, somewhere in the not too distant area, there was an earthquake. The earthquake shook the land surface, and you can see the result of the shaking of wet sediments in these contorted layers that we call seismites. This might have been a huge earthquake because we see things like this in similar age rocks in other parts of the state. After the seismic activity ended, more layers were laid down, one after another, long periods of time. We're back about 1.1 billion years, so we're in the sort of halfway back in the record of time of Grand Canyon. But after these layers get deposited one on top of the other, this layer ended up fairly deep and under pressure enough to turn the wet sands into rock. And then another thing happened. More water moved through, but only through the pores, like it was an aquifer or something. And it cemented the grains, the pore space between the grains got cemented with silica. And so this rock is a super resistant rock because of that cement, that silica cement between the sand grains. As a consequence of that, it's super hard for the river to erode through it. And so the slot canyon on the side, the river can only cut straight down. It's not enabled to widen. It's the same for the main river. We're coming to places where the whole Grand Canyon is narrowing down because the rocks are more resistant to erosion, and the river has to concentrate its energy in order to continue to incise through the hard rocks.